Ooh, this is a good question. How can today's biotech industry learn from the heyday of eugenics?
Well,
because the biotech industry is getting into CRISPR in a big way now.
That's correct. That's correct. And the evidence of that is that there is a huge dispute going on of international proportions, not to mention transcontinental proportions in this country, over who's going to get the patent rights
to
the CRISPR technology.
Yeah.
That's an issue we could turn to in a little while. But it seems to me unquestionable that there is going to be a very, very powerful impulse coming from the biotechnology industry to use this technology for some kind of enhancement or improvement, not necessarily to be transmitted in the germline. Let's be clear that there are two kinds of ways you can use the CRISPR technology. One is as the way we've been discussing, which is to say to change the genome, your genome in the germline that will be transmitted to the next generation. The other one, however, which is much more likely to come sooner rather than later, is to intervene in the genomes in organs that are diseased in your body, say the kidney or the liver or the lung, where cystic fibrosis, for example, expresses itself, or any organ that is subjected to some kind of oncogenic insult from cancer genes. So those kinds of interventions would not be transmitted to the next generation. The only ones that get transmitted are those that intervene in your sex cells or intervene in the embryo, or et cetera, in a dish. So we have to keep those two things separate. I think that the biotech industry is going to be a very, very powerful force in bringing about that second kind, namely the intervention of using CRISPR technology in disease genes that don't get transmitted to the next generation. At the same time, I can imagine biotech companies developing this technology in ways that might be effective in changing the genome down the germline. And I think that they will probably seek to get it approved. They'll have to go through all sorts of, jump through all sorts of hoops with the Food and Drug Administration, because anything that changes the chemistry of the body is, in the sense of a drug, not pot, so for example, but sense of a drug, is subject to FDA approval and regulation. So there is that safeguard. But I can imagine them bringing to bear pressure on FDA, which they have been known to do in the past. But I think another part of it that we could talk about at some point here is that the success of the biotech industry depends not only on its own technical prowess and the new technologies and medicines it produces, but also on consumer demand. Mm-hmm. Okay. And since 1986, drug companies have been able to advertise directly to consumers. That's by an act of Congress. And we see these ads on TV all the time, right? I mean, they're sort of frightening. The descriptions of the dangerous side effects seem to take longer than the descriptions of the advantages. But nevertheless, they're there, and they do generate consumer demand. So when we talk about biotech in regard to CRISPR, I think we have to talk about it symbiotically in relationship to consumer demand.
I can see it now. The ads for CRISPRing your baby. Right. Oh my gosh, you can see it, right? Like, this beautiful, perfect baby kind of drifting into view on a cloud. Right,
and the adult child playing the violin the concerto and the piano.
Caution, side effects might include thousands of years of torment, and it's going to be. I don't know. Do you think that we'll be seeing those?
Well, I mean, first of all, this is utopian.
No, I know, but I'm talking about just the ads.
Yeah, I know. Sure, I can see the ads. But in order to provide those, to mount those kinds of ads, you have to have command of the technology and the knowledge that enables you to say, if your baby has these genes, your baby is going to debut at Carnegie Hall at the age of 17, right? Mm-hmm. And nobody has the slightest idea what genes contribute to those kinds of talents, let alone many other talents that we all value and admire. So there is huge huge scientific barriers to that kind of thing coming along anytime soon. So, in my view.
Yeah, no, I agree. But I think maybe it'll be more sort of like people with a particular, hereditary diseses.
That's
I'm actually
correct.
thinking, I mean, you mentioned, sort of how CRISPR might be used now and, say to fix cystic fibrosis. Somebody has cystic fibrosis, it's the result of a faulty gene, and just CRISPR it and fix it. And this seems like it's going to finally achieve the dream of gene therapy, which people have been talking about for 40, 50 years. And right now, like the conventional gene therapy that doesn't use CRISPR, it's getting on the market, and they want to charge like $1 million a pop. So can you imagine like how much the biotech will want to charge to say like, we're going to fix hemophilia and you and all of your descendants, just for like $50 million, because it'll be worth it. Like think about if you were to, think of all of the cost of taking care of you with hemophilia and all your descendants. It's going to be enormous. Right. $50 million, it's a bargain.
Yeah, and we have precedent for that. We have to go on another question, but we have precedent for that in, all the way some drug companies are behaving these days in regard to the prices they charge.
Sure.
Like Gilead with Hep C.
And that's
tens of thousands of dollars.
That's just a conventional thing. I mean,
exactly.
Gene therapy, they actually literally someone wants to charge $1 million to fix it.
Here's a question that is a natural extension of what we've been saying. So, what are the technological limits of human enhancement? How will those limits shift in 10, 20 to 50 years?